another episode of Talking Kotlin. My name is Seb, as you probably maybe remember from the last 100 episodes, and I am once again joined by my lovely co-host, Márton. Márton, how are you doing?
I'm doing great. Hi, everyone.
Already feeling, the role of co-host for the show at this
Oh,
point?
yeah. Very much
Yeah.
so. I don't know if we need to do the weather segment again, but I'm
I
trying to be prepared.
I feel like okay. So you literally, I feel like you're really like trying to, maintain that weather segment for a little longer. But of course, if you have any ideas out there, dear listeners, for alternative segments that you'd like to hear instead in this new era of Talking Kotlin, we can once again encourage you to, of course, leave a couple of comments down below this video. Or I don't think your podcatcher is going to support adding comments. But Marton, you did rant about the weather before before we started here. So do you just want to very briefly repeat that rant for those people who are interested?
I don't know how much of our audience is those people, but hopefully we still have them. No, I mean it's a toasty 28.68 Celsius degrees in here. I wish the AC we have was in this room as opposed to the other one. But yeah, surviving. It's all right.
Hey, you
We'll
have
get
the
through this.
luxury. You have the luxury of having an AC. I'm not quite there yet. I'm just staring at the Google weather report with a giant red lettering that says heat warning. So I'm just gonna make sure I stay hydrated throughout this episode. Anyway, yeah, today we have a couple of wonderful guests who we're going to be talking to. And it's going to be slightly out of the ordinary, but still Kotlin related. Because today we're going to be talking to Abe and Marc from Skip Hi, folks.
Hey.
Hey there.
Hey, where are you folks located?
So I am coming to you from Houston, Texas, where the temperature is actually in the high 90s Fahrenheit with high humidity in the summer. So talk about toasty. We have plenty of that, although pretty much every building you will ever visit in Houston is air conditioned.
And I'm coming from Boston, Massachusetts, where today, unlike the past couple of weeks, it is a beautiful 72 degrees Fahrenheit, which I believe is around 20 degrees Celsius. So quite lovely.
That is very nice. I am very jealous of the 22 degrees. Not so much of the Texas humidity heat. Awesome stuff. Okay, so you folks work on Skip tools. Do you want to give us like the brief elevator pitch of what it is that you folks do?
Yeah, absolutely. So Skip is a tool that allows you to bring your iOS code base to Android. And basically what it does is you write a modern iOS library or app using Swift and or SwiftUI. And we translate that into Kotlin and adapt it to Compose in the case of SwiftUI.
So that's a pretty novel idea. I don't think we've seen a technology like this before. I think the first question we have to ask here is, how did you come up with this? Maybe like what's your background that you ended up approaching the the multi-platform development thing from this direction?
Sure. So I mean, we could go way back in our history. We have a sort of varied history with going back and forth between the Java world and the iOS world. But the more immediate history is that we got together after not working together for many years, and we wanted to work on something that was related to actually sort of sending UI down from the server. That's how things started. We started exploring sending down SwiftUI. We built up a whole system around it, got pretty far, but the entire time we were wondering how we were going to tackle the Android world because we were writing Swift code. We were doing it primarily for iOS first. And Marc kept throwing out ideas for how we might address Android. And one of them was that he stumbled upon an open source transpiler from that transpiled code from Swift to Android. And it didn't handle a whole lot of things, but it did sort of give us the idea that, hey, this might be a thing that's possible. And so we went about prototyping our own transpiler and seeing if we could handle, more of the hard problems that come up when you try to adapt these two languages. And then also prototyping whether you could, change SwiftUI into Compose and actually get a UI running. And as we prototype more and more, we kept trying to find blockers and then being able to overcome them. And so we decided that this would be an amazing product to be able to deliver to developers, to be able to write iOS code and basically have sort of this robot Android team working on your behalf to give you an Android app as well.
So do you still have any of that idea of powering the UI from the server side in any way in
We
Skip?
have the code, but it's not in our product right now. It was definitely a pivot.
So was this just the classic like pivot of saying, hey, we're we've in the process we've stumbled into something that happens to do a related thing really well, or was this something where you said, or where maybe the trends are going a different direction? You're saying, oh, we're not actually seeing that much interest for server driven UI, but there is more interest for this kind of like transpilation side. Like how was this decision made?
Right. It was more of a proactive pivot. We thought the server-driven UI idea is interesting, and we're keeping it sort of in our back pocket. We know a lot of companies are working on that, but it's always in sort of a gray area, especially, well, actually for both Apple and Google. There are certain guidelines that you're not sure you're running afoul of or not. And while companies are doing this, we don't know just how powerful you can get in terms of what you can deliver via the server until sort of Apple or Google might just say, no, we're not going to allow that anymore. Uh, so this idea seems safer from that perspective, but also just once we realized sort of how powerful it is, we just thought it was a much more interesting and useful idea for developers.
Yeah. Um, it's interesting that you especially bring up these like App Store guidelines, because we did have this discussion a little bit also at a couple of conferences. Because of course we also with Kotlin multi-platform we're getting a lot of this feedback as well. Like there's people building server-driven UI frameworks and so on, and like a lot of people really try to get the, for example, A/B tests and all of this like pushed right into their apps. And for those kind of scenarios, yeah, the phrasing is a little bit vague in that you're allowed to do some sort of modifications as long as the core app experience doesn't change. But I mean, what what that exactly means, I guess, is always a little tough. Okay, very cool. So, clearly, let me phrase it as an open question. Would you say that your target audience for Skip? Okay, let me take one more step back. Is it called Skip Tools or is it called Skip?
We generally refer to it as Skip, and we refer to ourselves as skip.tools.
Okay, gotcha. Okay, so is the main target audience of Skip iOS developers specifically, or do you see a broader audience for Skip?
We definitely see a broader audience, but the people who are going to gravitate to it first, I think, are primarily iOS developers, people who feel comfortable with Swift and SwiftUI, and who want to sort of get that Android story for cheap. um, but certainly, we think it's an idea that has merit for anyone who wants to target both the major mobile platforms. I mean, there are really only two players these days. You've got iOS and Android. If you only write for one of them, you're missing out on half the audience potentially. And the other alternative is to write your app twice, or to use a tool like this. And you've got Kotlin multi-platform and React Native and Flutter, and we're sort of a new entrant there.
So do you mean to convince eventually Android developers to also take a look at Skip? Like, do you foresee teams where most of the code is written by iOS devs and uses Skip, but there's also someone on Android. You had this, I think you said that the idea is that you have this robot Android team that does most of the Android work for you, but do you also imagine that, there would be like maybe one Android developer still doing some Android stuff next to the people mainly writing Swift?
Yeah, I mean, we definitely don't think that this would like eliminate, Android developers in any way. It's more of a way of bringing things together from, both sides of the development teams and having sort of a cohesive platform that is sort of iOS centric, but does not preclude, there being Android and Kotlin developers on the team because, there's sort of the fast track, simple path towards a simple application that you can create if you don't know any Kotlin, if you have no Android development experience. But really, once you start getting into the depths of things, like getting into really sophisticated frameworks and things like that, then you probably will be having a significant Android contingent, and also people who don't want to be constrained by developing in just Xcode, just on Apple platforms and things like that, right? You can use the whole variety of JetBrains IDEs to create things like Kotlin multi-platform modules, which we integrate with. So yeah, so it definitely is not the idea that we will just like eliminate all Kotlin Android development side of the team. It's more of a sort of path to creating things that comes in it from sort of culturally a little more of the iOS side, I would say.
I'm quite excited to also hear about the Kotlin multi-platform integration, and of course, I think I'd love to touch on a little bit more about this and just really dive into how all of this works because it does seem quite a little bit magical. But just so that maybe we also just have a good idea, like where do you consider Skip to be in its like development process and like the adoption that you've seen so far? Because I think your version number currently still starts with a 0, but if I've learned anything about semver, it's that semver doesn't matter. um so yeah, just curious, like what's the current state? Do you have folks like already using this? Where are you at there?
Yeah, we have quite a large base of people who are using it either at the evaluation stage or who have gone and purchased it. And actually, by the time this podcast posts, we will have released 1.0. That's actually coming likely by the end of the week. So yeah, so we're essentially at the point where the tooling is mature. People are creating apps. There's apps shipped to the App Store and to the Play Store using it. And and yeah, we're pretty happy to have a solid 1.0 out there, and we're gonna continually be iterating, because there's sort of two sides to the tooling. There's the integration with the IDE, and the ability to take your Swift and turn it into Kotlin, so that you can have just a single code base on that side. But then there's a framework support. There's a whole variety of frameworks on the iOS side. Um, there's Foundation that has sort of low level types, and then there's high level SwiftUI. But there's also a million other things, like things that talk to Bluetooth, things that interact with the media library and camera and things like that. And those are some of those are sort of nascent additional frameworks that we have that are could be using a lot of custom Kotlin, a lot of sort of low level Android APIs that don't have exact matches on those two. And those frameworks are still constantly evolving. So the tool and product itself will be at 1.0, but some of the sort of constellation, the ecosystem of libraries, those are going to continue to evolve on independent paths because they're all independent open source libraries that you can add or remove to your project as you need it.
Speaking of Semver, we were actually debating whether we actually wanted to tag our various frameworks as 1.0 or to leave them at their current 0. Whatever. They all have various versions on them right now.
That's a constant challenge. When when you say that something is stable, people will will always have expectations, and you'll always have people who won't touch something until it's stable. So that's always a game of versioning and and messaging and stabilizing. I wanted to ask, you've mentioned that some of the parts are open source, some of the parts you can purchase. Can you maybe describe what the different components of Skip are and how the licensing works, perhaps?
Yeah, absolutely. So the only part that's closed source is the transpiler itself, the part of the tool that takes your Kotlin, I'm sorry, your Swift and SwiftUI and turns it into Kotlin. The rest of it is open source. So our reimplementations for Android of the foundation library that iOS has, of the UI layer. So all the way that we adapt SwiftUI to Jetpack Compose, and then the various other modules, Firebase support, things like that. That's all open source. And the way the licensing works is you purchase a per developer annual subscription to use the transpiler. So conceivably, you could, purchase it, or there's a monthly plan. So you could purchase it for a month, run it on some code that you're developing, and if you want to take it from there and maintain it separately as a bunch of Kotlin code for your Android version, that's okay. You could actually cancel your subscription and you'd be done with using Skip. But as long as you want to maintain sort of a single Swift code base and continually run Skip to create the Android version as you evolve that code base, then you'll want to stay subscribed. And there are various plans. We'll actually, with our 1.0 version, we'll be unveiling a free plan for indie developers. And then there's a small business plan and a professional plan, just depending on sort of the revenue of your business and how many apps you want to release and things like that.
I think we have I think we have multiple follow-up questions probably. So on the open source part, as we were looking at Skip, I saw that you had a webinar where you described how people could contribute to Skip itself. So implement some of the SwiftUI features, for example, map them into Compose and such. So this being a large part an open source project, have you seen external contributors at this stage?
We have actually. That's picked up recently, and we've been very grateful because we've gotten some really good stuff. A couple that come to mind recently were someone implemented audio recording and playback using the Abe Foundation API on iOS. So the way a lot of our API works is that we try to just mirror the iOS API exactly. And that way, when you're writing your Swift and SwiftUI, your iOS sort of code base, you just have one code path. You're just writing an iOS app exactly as you normally would, and it gets translated to Android, and you don't have to ever import skip libraries or anything like that. It's totally transparent. So when that's an option, that's the road we take. So what this user was able to do is take the standard audio APIs on iOS and mirror them for the Android translation, so that when you're writing your iOS app, there's no imports of skip or anything. Actually, in this case, you'd have to do a quick little import toggle, but your code would be exactly the same. There'd be a single code path that's not using any proprietary APIs of ours. It's just using the normal iOS API. And that'll get translated, into the correct Android API under the covers. So another one someone did is our Firebase support, and that's implemented in a similar way where you're coding to the official Firebase API, and it's just using the Android one under the hood for your Android app. And they, we had started that. We had various support for Firestore and some other things, and they've just taken that and sort of run with it and started enhancing that to bring more Firestore to Skip. More Firebase to Skip. Excuse me.
So isn't it like an incredible amount of work to re-implement and bridge all of these APIs? Coming from an Android background, if I start thinking about all the APIs we have available on Android, and if I had to re-implement those on another platform with all of their parameters, behaviors, edge cases, it seems like it would be a very hard to tackle problem. Like how do you see that?
Yeah, I mean, it is a challenge. One thing they'll say though is that it is actually considerably easier going from these sort of iOS frameworks to Android APIs than vice versa, because just sort of historically the iOS and UIKit and Foundation APIs are a lot kind of more coarse grained and chunky. So like on Android will often have things scattered around many packages and many classes, and have very sort of fine-grained API access. On in the iOS frameworks, you'll often have fewer methods and perhaps more limited functionality out of the box. But it does make it a lot simpler to go that way than it would be to go the other way. Um, but yeah, there are a lot of challenges with it. There's a low level and there's a high level. Really, there's the foundation types, which handles things like URL and data and things like that, and those are often mapped to sort of foundational Kotlin types. We'll do Kotlin, byte array, and we'll do the URL, loading mechanisms and things like that. And then there's a high level stuff, which is the Android APIs and the Compose APIs and things like that. And we found that sort of the lower level things tend to be pretty straightforward one-to-one mappings. Like on both platforms, kind of a byte array is going to be a byte array. You can't really have variation in behavior of that, right? High level, you have a lot more nuances that in some cases we just sort of need to take one convention and apply that to the Android side, and have that be the default behavior. But one of the things that we're really proud about with Skip is that nothing that it ever does constrains you. You can just sort of drop Kotlin directly into your Swift code using a special precompiler declaration, if Skip. And in those cases, you can just write raw Kotlin. So if anything that we're automatically transpiling is not sufficient, or doesn't look quite right or feel quite right or use the API in exactly the right way, you can always yourself just drop code, directly in there, either inline within the Swift or as external Kotlin files, and then that presumes some understanding of Kotlin, of Android APIs and things like that. But it means that you're never going to be constrained by the path that we take for that translation.
And just to build for a second on what Marc said, I've very often thought to myself that going the reverse direction with Skip would be impossible. That if we wanted to take Kotlin and Compose and turn it into Swift and SwiftUI, API-wise, there's just no way we could do it. The language, fine, but in terms of these APIs, there's no way we could map them because the Android APIs are often so much more fine-grained. You have so many more options. It really only works in the direction we think that we're going, because SwiftUI especially, this comes up often. It's just so much more coarse-grained, as Marc said. There's so much more of a limited API, that we are able to take it and use all the rich API that Compose offers, all these options, all the way you can dig into the low levels to be able to mirror the SwiftUI behavior. And if we tried to go the other way, there's no way SwiftUI has enough sort of fine-grained options on it to be able to mirror the Compose behavior.
So I'm still a little bit curious about what parts that I can share with Skip. I'm also interested in like diving a little deeper into how that actually like works. Because okay, let's maybe actually do that one because that one can be handled a little quicker, and then we dive into the other part. So you said like all these libraries that do this, they are open source and they're not part of the like transpiler. Did I understand that correctly? So what do these libraries look like? Do they have a like a proprietary or like custom like header format that says here's the Swift declarations, or here's the like API surface, and this is how we would like for them to be implemented in Kotlin, or how does this connection happen?
So our core library is what we call the Skip stack, is a set of 5 different modules that is separate from the transpiler. They're all open source libraries, some of which the transpiler assumes are present. So either the ones that we ship or some fork or modification that someone would make. But they're sort of at the lowest levels, there's sort of Skip Foundation, and then there's some intermediate layers like Skip Model, and then higher layers like SkipUI. And all of those are transpiled just like your own code is transpiled. So we actually write those in Skip itself. In Swift itself. And then it's transpiled along with your whole application into into the end product, into the Kotlin code, and then the APK that winds up getting put on your device. And the way that works is that in Swift you have project dependencies. Your Swift module will depend on another Swift module, and you can reference it by URL. It's very similar to sort of Gradle dependencies. It's just got its own quirky way of doing it. And so whenever we transpile a project, we transpile not just your own code, but transitively all the dependencies that you have that are skip enabled. And we have a skip YAML file that sort of configures the details of that. So essentially, every time you're building your project, you're also building sort of the entire world of modules, both these core skip stack modules, as well as any additional optional modules you have, like say Firebase support and things like that. And that's all brought to you down automatically by the Swift package manager. So you have that all present, all that source code present on your own computer, assuming it's not a precompiled binary package like say that like Kotlin multi-platform additions. Those would be sort of binary dependencies. But anything on the Swift side is all transpiled all along with your own project. And so any changes that you might make to any of these foundational modules, those will automatically be transpiled again and included with your app.
And just to give you a picture of sort of what the code looks like, imagine, let's take the URL example, right? So Foundation on Apple platforms has a type called URL. And so we can basically just take the Swift sort of headers. There's no Swift headers in Swift, but take the Swift definition of URL and get rid of any implementation code. And then if you imagine us implementing it, so we'll start with just the API definition. So we have a URL, struct URL, and it has these constructors and has these functions and these properties, right? And then the way we fill that in is, okay, what do we do in a constructor? Well, we'll create a JavaNet URI or URL. Just in our case, we use URI, but whatever. We'll create the equivalent from the Java or Kotlin world. So we'll have that as our member variable, right? And so then we start implementing all the functions and properties. So URL has a host property. What does that need to do? I'm sorry, Foundation URL has a host property. What does that do? Well, it just calls the Java URL's host property and returns that, right? And the thing that you have to sort of get your head around is this is all being translated from Swift code to Kotlin code. So as long as the code matches, it's gonna be correct, right? And so that's all you really have to do is figure out how to take the API that the Swift developer is used to. So we just dump those APIs from the official Apple, stuff. And then we fill it in. How do we fill it in a way that is going to do the right thing on Android? And typically for things like URL or data or something like that, it's just constructing the equivalent Android type and then just delegating to it for most of the functionality.
Okay, I think I'm following. So we're instantiating Android Java types, and we're wrapping those with these Swift constructs, which have the same signature as the original Swift APIs, right?
Exactly.
I think the part that's hard to get our heads around a bit is what does the syntax, like the actual source code, look like for this? Something you've mentioned previously is you can like just drop Kotlin into your Swift files, I believe, and that somehow gets transpiled, but I'm not super clear on how that works.
Yeah. You can, so there's two options really, and we have other smaller mechanisms, but the main two options are you can, one, just take literal Kotlin files and drop them into your project, and they'll get built along with the rest of your Android build. Okay, so that's one thing you can do, and that's just pure Kotlin files. The other one is you can call Kotlin and Java API from your Swift directly without any bridging or anything. And that's because, again, we are just translating the source code. So if you write foo.bar in Swift, it will get translated to the equivalent foo.bar call in Kotlin. And the syntaxes are close enough that you can basically just write idiomatic Swift, and the transpiler will do a little work, and it'll turn it into fairly idiomatic Kotlin. So there's no sort of JNI bridging or anything else going on when we're talking about delegating to the internal Java type. We're literally just invoking its functions as you would do in Kotlin, but we're doing it in Swift.
But because it's guarded inside of these special precompiler statements, obviously, if you're writing this in like Xcode, Xcode has no idea about Kotlin, has no idea about what the dependencies and the available functions are. So you are doing a little bit of sort of blind developing. You're getting no help from the IDE. So that's sort of the downside to that. It's nice for a quick toggle, like, if I'm on iOS, then use this API to get the system preferences. Else, if I'm on, Android, use this Kotlin Android API to get the preferences. For more advanced, sophisticated stuff, you will almost certainly be writing in, IntelliJ or Android Studio or something like that, and then integrating those raw Kotlin files into your project, because you can only do so much blind coding without the help of a real IDE.
Yeah, I was about to say, because if you kind of like, I'm obviously in my head always reevaluating this with the opposite direction that we have with Kotlin multi-platform, because that's the one I'm most familiar with. Where of course, like we're now like working on all of these things, like cross language like navigation, cross language resolve, precisely because, as you say, like when you have to like code blind, or when you don't have the tooling support, that all of that becomes a little harder, especially like the moment you actually want to integrate with like platform specific, like deeper APIs that have some wacky things where you, I don't know, describe some object that takes callbacks, which is like a lambda function, or which is like an object declaration and has like a bunch of other things with receiver types, and so on. So, but it seems that having the ability to have just entire Kotlin files, and then essentially just constraining the IDE less part to pretty much just the headers that call into that file, might make that at least bearable, right?
Yeah, and one of the things, our Skipstone plugin build plugin does isn't just translate the Swift source files into Kotlin source files. It also translates your project, your Swift package manager project, into a Gradle project, or actually a network of Gradle projects for all your dependent modules. And then that output is essentially the pure, Android Kotlin project that you can do with whatever you want. And in the example of integrating your own custom Kotlin code, you can just open, the top level settings.gradle.kts in, say, IntelliJ, and be able to, just go from there and work on the Kotlin side of your projects directly. And that's the way that we sort of see people integrating with the Android team, on your apps project, is basically having the ability to have them take the entire project and be able to just like go with it, and then they'll be able to commit changes to the pure Kotlin side of it, and then that will reintegrate with the iOS. Now, you can't make changes to the transpiled output. It's a one-way transpilation process, but the parts of your application that do have custom Kotlin code in it, those are things that you can edit in any IDE.
Okay, makes sense. So you can have those Kotlin files that are part of your like starting sources to begin with, that your Swift references, and that you can edit independently in like IntelliJ or something like that. But the output you're not allowed to touch because it's going to be overwritten anyway, right?
Yeah, so basically the result of these Swift files themselves, those will be essentially read only on the on the Android, on the Kotlin side. But the raw Kotlin files that you're integrating into your project, which could be a large chunk of it, are free for all to edit on either side. Um, that, and of course, you can also just integrate with a Kotlin module, Kotlin dependency directly, right? And go through the entire Maven publish, format in order to integrate that into your project. And that's another route to go if you have sort of a well-defined pocket of functionality that you want to bring into your application. And that would be more like a binary dependency, like the way that we integrate with Kotlin multi-platform.
So I'm still my mind was not able to entirely let go yet about this idea of just being able to, or about this re-implementation of a lot of the like foundational APIs, or I guess just APIs that I as an iOS developer might have available to me, because I'd love to get a little bit of a better idea of like kind of where that line is maybe drawn, because in my free time, sometimes I sit down and my YouTube algorithm feeds me fun videos from WWDC, and I get quite excited when I see about, like, I don't know, accessory setup kit, or like, I don't know, some changes in core Bluetooth, or like all these kind of things, right? Like biometrics, like, and then of course also this going up to like the UI stack, where like you might have like the map views, or like, I don't know, AR integrations, all of this. Um, so where does Skip like currently draw the line here? Like, do you have like an MVP that's kind of like outlined, where you're saying this is what people need the most, so this is what we're going with? Is there more of a completionist approach? Where are you sitting here?
Yeah, I think we go with more of the former, at least to start, right? So we have a fairly complete implementation of the Swift standard library, because you tend to lean on that heavily. Foundation, we do the most useful things that people tend to need, like networking and all the base types. Um, and then as you move up the stack, there's sort of more sparse support, right? SwiftUI also, though, is pretty complete, but it's a giant API. You can think of Compose and just all the intricacies there. So we have taken the things that people use most, and we document everything that we support. So you can always reference, go to our framework references and see what is supported and what's not. Um, and then, I mentioned some of the audio visual stuff. So we have some support for AP Foundation and AV Kit. A user right now, speaking of contributions, we see is working on core Bluetooth, actually. You mentioned that one as something you've seen in WWDC. That's something someone is working on. But yeah, it gets more sparse sort of as you move up the stack and as you move into things that people use less often. And sort of the thing that we pride ourselves on, though, is that we have covered most of the most useful things, and also that it is so easy to contribute, because we have this sort of no bridging ability to call into the Java sort of Kotlin world. So often, if there's an API that you need, it's really not hard to add it to one of our libraries, or as Marc said, you could just call it directly in your own code, just as a workaround for something that we're missing. And then there's just to finish the thought. As you get into the more complex things, there would be no way to probably do those in an API transparent way anyway. So there'd be no way to translate from perhaps Apple's Health Kit to Android's equivalent, or some of the more advanced sort of kits that you get, they probably implement in fairly different ways sort of as you move up the stack. And so you'd end up doing it twice, regardless of what sort of framework you're using, or creating a proprietary API that delegates to one or the other. There's probably no unification possibility other than creating your own API anyway.
Yeah. So just looking at this a little bit from the Kotlin multi-platform perspective here, at least for a certain number of APIs, I feel like the community is definitely trying and coming up with like a good intersection of the main use cases. But oftentimes, of course, if you have something that is really platform specific, then people would kind of like branch out, and they would, for example, have like in the example of a room, right? You would have, because you have different so room, the persistence API, right, the database stuff, you would have different places where that database might be stored, right? You might handle that differently on desktop or on the web with local storage, or on iOS and Android. You would have like different entry points, or like different constructors that you would then like somehow wire together with like dependency injection. But yeah, of course, if you're like really the moment you start going like really deep into a platform specific thing, and you need the entire capabilities of that, it's gonna get harder and harder to extract something that behaves exactly the same everywhere, and that's like semi well documented at that as well.
And that's why we think there's always room for having Android developers or learning the Android side of things yourself. And we've definitely seen some of our users sort of take Skip and use it as a bridge into that whole world, because, as you said, once you start delving into the more detailed platform capabilities, there's no papering over the differences, and you're going to need to learn about those differences and how to use them.
One part that I can't quite still place here is, funnily enough, we've said a lot. I've talked about room. You've said there's a lot of room to learn. So I am curious. I'm sorry, Márton. I am curious about what the story for like local database and persistence is, because again, when we look at this from like from the Kotlin side or from the Android side, like the go-to thing is Room, which is like a KSP plugin, right? That's a symbol processor or like a lightweight compiler plugin that requires customized it requires customized Gradle configurations. It's like pretty heavy on like annotations. So that sounds. I, I'll keep it open. What's the story for data persistence currently with Skip?
Yeah, our current data persistence is we have nothing like Room on the on the Skip side, unless of course you integrate a KMP component that uses Room, in which case you would have it on both sides, because I know that there are some KMP Room libraries in use, but yeah, from the pure Skip side, you have you obviously have file persistent storage. We support codability to JSON files and things like that. And you have the, various...
Could you expand on codability a little bit? Because that is not something that's as built in on the Kotlin side.
Oh, yeah, right. So you have the notion of being able to automatically serialize types into data structures. It'll typically be JSON, data. That's just kind of the default encoder and decoder. But yeah, that's sort of an attribute that is supported at the lowest level in Swift, that you add to your types, and then they have the ability to either automatically or with varying degrees of customization take your type and serialize it directly to a blob of data, usually to store and read from a file. And this is similar to some of the Kotlin serialization libraries that are sort of add-ons to the platform. But this being baked into the Swift language, the Swift compiler automatically fills in all the blanks for encoding and decoding things. And that's one of the enhancements that our transpiler makes to the Kotlin that it winds up generating, is it adds all of the necessary sort of plumbing in place to be able to do that in exactly the same way on the Kotlin side. And so that's basically the simple persistence story for, say, file-based things. For databases, we do have one of our ecosystem of libraries, is SkipSQL, and that sits on top of the SQLite library, the C library, on both the Android and the iOS side. And that basically lets you write raw SQL and be able to create and read and save to a database. Beyond that, we don't yet have anything. We've considered doing something on top of Swift Data, which is sort of Apple's equivalent of Room, their modernization of an older core data platform, or doing something externally. But for the time being, we really just have the ability to manually be able to create a database and execute insert and update and delete statements and things like that.
And then, of course, now people are moving to things like Firestore and things like that, which we also have libraries to support. But for local persistence, SQLite is our primary mechanism right now.
Yeah, it is very funny that all of these libraries end up being underpinned by SQLite anyway. I think from core data to Room to whatever, you always have that as the underlying database driver. But yeah, my original question was because Apple being pretty prescriptive in the way that you structure things. Like I think a lot of people would immediately go to like core data, Swift data, like as like just the go-to thing. So I was curious if there was something there. I'm sorry, Márton, I talked over you.
That's all right. I'm wondering about the codable parts. So you've described that you have to do the same work that the Swift compiler usually does to make things serializable. So for that, would you, for example, use something like Kotlin X serialization under the hood to make it work? And that's probably a more general question. Like, as you're re-implementing all of the platform APIs, like networking, do you go for very low-level solutions on the Android side? So maybe HTTP URL connection from Java, or do you perhaps depend on the established libraries like HTTP? Like, it seems like there are, dozens of interesting questions like that as you're going through the APIs and re-implementing them.
Yeah, we really take it on a case-by-case basis. So we initially try to just use whatever Android developers would typically be used to using. So just to answer these two specific examples, because they're illustrative, for codability, we could not use the built-in serialization libraries or the available serialization libraries because they won't serialize the exact same way as Swift does. And one of the typical use cases for codability is sending data to and from a server, right? And so you need those formats to be exactly the same. So for that, we just mirror what the Swift compiler does so that we get the same output and ingest things the same way. For networking, we chose to go with OKHTTP, which you mentioned, just because it's sort of the established library. It has a bunch of conveniences. We actually started with some of the built-in Java stuff, and then we needed to add WebSocket support. And that's when we sort of made the jump to OKHTTP and just redid our base stuff using that. So yeah, it's really just case by case. We just try to use whatever is going to give us the best functionality, but it does have to match. So sometimes we have to go lower level to make it match.
On the JSON side, maybe we don't want to get lost in this specific topic, but I am curious about what the Swift implementation does differently. Like, I assume it's serializing into JSON, right?
It's
but
closable,
you said that,
but the JSON is obviously the most common.
Yeah, but you were saying that like something behaves differently and you couldn't achieve the same output with Kotlin X?
Yeah, I actually don't remember the details of that. Mark, if you do, feel free to jump in. But sort of the gist was that it was either not obvious how to get it to behave exactly the same way, or it would have taken a lot of sort of configuration of that system, or it wasn't as flexible, perhaps at runtime, because code generation obviously is happening at compile time, but at runtime, the JSON encoder and decoder from Swift offer various options. I honestly couldn't tell you. I don't remember the details, but we wanted to be sure that whatever you're communicating over the network is exactly the same, because you're going to be talking to a server, and it shouldn't have to understand two different dialects of JSON depending on which language or which platform you're coming from.
Yeah, of course. And then for a more general question, which is applicable to all of these re-implementations of APIs, do you have a good way to test that your implementation is doing the same as the Apple implementation? Like, can you write unit tests across all of these API surfaces?
Yeah, actually, one of the sort of undersung features of the skip transpiler is that it transpiles all your source code, but it also transpiles your test cases. In Apple, there is a testing framework called XCTest, which is a pretty blatant re-implementation of JUnit, which is sort of the granddaddy of them all in terms of test cases, and it's got XTC, XCT, assert equals, which is just JUnit assert equals. So actually, one of the things that we do is when we see your test cases, we translate your idiomatic Swift test cases into JUnit test cases. And we also generate, a Kotlin Gradle test module and things like that. So we actually built in the ability to take your test package for any of these, individual standalone modules, be it our own, like Skip Foundation or SkipUI, or one that you are writing, and be able to have consistent test cases, and then you can just run it from within your IDE, and it will run both sides of the test cases. So it will make sure that on, the Apple platforms, 1 + 1 = 2, and then it will take that code, it will transpile it, it will run it in the Gradle JUnit test harness, and then it will, assert equals 1 + 1 is 2. And that's really how we maintain the quality control of our own frameworks, right? We have this built into our continuous integration, which runs on GitHub Actions. And every time we push to it, it goes through test suites of thousands of tests to make sure that the behavior is exactly the same on both sides, both in local testing. On Swift, you run on Mac OS, and you can run on the desktop using the Roboelectric testing framework for sort of fast local testing, but it also connects to an iOS simulator and an Android emulator, and sort of takes those four variations of the way you can test things, and make sure they all run exactly the same.
Yeah, I think this sounds very familiar to us from the Kotlin multi-platform perspective again, because there as well, we aim to write a lot of common tests, and then you can execute that across all of the platforms that you're targeting. So you can have one test and then run it on maybe 6 different platforms at a time, 15 different platforms at a time, with all the architectures and variations.
Yeah, here we also I do remember this for a couple of the internal tools that we have that have a native component and a JVM component. The fact is just that with the JVM, you can, at least in the Kotlin world, you can compile a whole lot faster than for native code. So essentially, to quickly iterate on APIs or behaviors, you could always just run the tests. Like, you might only have a JVM target just to run the tests, and then for actually shipping the command line tool, for example, you just put it out as native. One of the examples where we do this open source is KDoctor, which is the environment check tool that makes sure your Xcode and everything is set up. So you can take a look at that on GitHub, dear listeners, if you're interested in that bit. Now, we are we've really gone quite deep here already, and we're slowly running out of time. But I am still curious a little bit about the fact that, of course, Skip doesn't just do foundational stuff; it also does SwiftUI, and I'd like to just understand a little bit better about how that works, because I'll be honest with you, again, seems like an incredible proposition. Also seems very, as someone who over the years has gone through the iceberg of complications in Compose, has I'm very curious to see how, or to learn a little bit more about how this mapping actually works, right? Because I don't know so much about SwiftUI, but at least in Compose, right, there's a couple of very typical idioms, right? Like, you have your typical slot APIs, the actual composable functions determine kind of the re-rendering boundaries. Like, you have all of your effects, some of them with cleanup, some of them without, for side effect stuff. A lot of state management is typically done using flows that are then turned into some kind of compose state objects. You have these derived states for when you need to do things that update more quickly. And again, I'll keep this kind of question open here. How is it feasible that you can turn SwiftUI code into Compose code? And how far would you say is that generated Compose code from what an Android developer maybe might write?
Right. So this is one area where the transpilation is not at all idiomatic, because the systems are just so different. So typically, when we take our Swift code, and if you see the output of our transpiler, the Kotlin looks like something someone might have written. There's some mechanical stuff in there every once in a while, but for the most part, it's very digestible, and most of it looks like something someone might have written. When you see the transpiler output from SwiftUI, it does not look that way. And so we call it more of a SwiftUI as an adaptation layer or something like that, our SkipUI library, more than a transpilation. Just because the systems are different, SwiftUI is built on view structs. So you have this whole graph of objects, whereas compose is function based. It's just a very different world. But under the hood, we're tying into all the compose mechanisms. So, for example, even if you weren't translating SwiftUI, let's say you just want to share your business logic and model layer. And so you write an observable type in Swift. Under the hood, when we translate that into Kotlin, we're going to back its observable properties by immutable state that's going to integrate with your compose. So that as you change those, they're also, they're observable in Swift on the iOS side, but when it gets translated into Kotlin and run on Android, it's also, those changes are going to be observable to compose. So you can just drop them in and use them as models in your compose code as well. And we take advantage of that in our SwiftUI translation also. So SwiftUI and compose, they are both state-driven, reactive sort of frameworks. So whenever you declare sort of state, the officially tracked state, like mutable state and compose, the SwiftUI equivalent, we're going to back it by, compose's mutable state. And there's some translation also from like async sequences in Swift to flows in Kotlin and things like that. But basically, getting the state part right is a major aspect of it, right? Being able to just manipulate state and make sure that the system is able to react to that gets you a long way just in itself. So we do that part, and then the rest is sort of just adapting SwiftUI's various UI components to the equivalent composable functions and SwiftUI's various modifiers to building up the right, modifier chain in compose. Or sometimes a SwiftUI modifier doesn't translate exactly, so we have to sort of create a sort of wrapper view that does some logic and then calls compose on the that sort of view that you're modifying. If you looked internally, this is sort of the most complex, I think, system we have, the farthest from just a one-to-one mapping of anything. But once you sort of get into the framework and understand our SkipUI framework and sort of understand sort of the basic architecture of it, once you dive into individual components, it is pretty easy to see sort of, eventually if we're calling the same compose component. We might do some work on top and adapt things in various ways, but when you use text into a text element in SwiftUI, we're mapping it to a material3 text in compose and so forth.
Yeah. So it's mechanically doing the same thing as you do in compose, but the sources with this bridging look different.
Yeah. Very different.
So I guess that's another reason why you wouldn't want to edit into your like transpiled output, right? Because
right, we do have mechanisms, like we have something called compose view. So in your SwiftUI, you can just drop in, you put in compose view, and it takes a block, closure, and within that you can just call compose, directly, however you like. The closure, takes in the modifiers that have been built up by your SwiftUI modifiers, so that gives you this sort of compose translation of the modifier chain, and you can just start calling compose functions within that. And then if you want to branch back into SwiftUI, you can just instantiate any SwiftUI view from a compose view, from a compose function. You can instantiate a SwiftUI view, configure it, and then we add this compose function to all the SwiftUI components, and you call compose, and then it's just going to compose right there. So you can really move fluently between the two worlds. And sometimes you have to take advantage of that if there are things that we don't support, or you want to do something very platform specific that doesn't exist in SwiftUI.
All right. As we are running out of time, I really wanted to ask a question about tooling. You've mentioned that you work in Xcode a lot. Obviously, that's your primary target for writing Swift code in. But you also work with Android Studio or maybe IntelliJ IDEA, I'm not sure which one, for writing some Kotlin parts and implementation, perhaps. So, do you have a comparison of those two tools? Because I think you're in an interesting position where you actively work with both IDEs.
Yeah, I mean, we're definitely most familiar with Xcode because our most recent jobs have been on the iOS side. The last time I did Android professionally before this, it's been a number of years. So we're familiar with Xcode, and I think people tend to enjoy what they're familiar with. So I definitely don't see some of the, Xcode gets a lot of hate, I'll put it that way, online. And I think it's actually a very decent IDE in modern incarnations in any case. But some of the things I really enjoy when moving to Android Studio is what I primarily use when doing Kotlin work. Definitely things that jump out are like the speed is crazy when you're just iterating on something small and you make small changes. Just the fact that Java can, do file by file, or Kotlin do, basically file by file, compilation, and then there's no major linking stage and all that. Anyway, but you can iterate very quickly with minor changes. And then it just has a lot of niceties that I think have built up over time because JetBrains is more responsive, I think, to developers. Just very minor things about the way it shows you how code aligns and some of the affordances you get in the tooling I enjoy. But I don't see any sort of fundamental differences between the two. The iOS sort of Apple world is much simpler in terms of configure dependencies and things like that. I find that much easier to understand on the Apple side. But I find the tooling to be fairly similar overall. I don't know, Mark, if you have a different perspective.
Well, yeah, there are a couple of really big exceptions, like refactoring in Xcode basically is
Yeah, I just don't use it.
in the Stone Ages. It's compared to the JetBrains tools where it's incredibly sophisticated. Like you can do all sorts of things with the built-in refactoring tools. They've just never been good in Xcode, and going back to the Objective-C world, and they're still very primitive when they work at all. So there's a lot of things like that are huge advantages in the sort of the JetBrains tooling world. But generally speaking, sort of the philosophy of transpilation extends to the IDEs in the sense that we want to let Swift be Swift on iOS, and we want to let Kotlin be Kotlin on Android, because those are the two recommended languages for those platforms, and we think that those are the ways to make the best apps for those platforms. And similarly, we don't think that anyone's going to be writing a lot of Kotlin in Xcode, and probably not a lot of Swift in IntelliJ, although actually I've not experimented with the capabilities of different languages very much. Just because the clear focus of things like Android Studio and Xcode are for the major platform that they support, and so that's why we spend a lot of effort in making sure that's not just the code that we transpile, but also the whole project, so that you can really go with the IDE that works for you, including refactoring tools and code insight, and being able to run test cases, and also like the debugger, right? Like there's no way to debug your Android app from Xcode. You can run it in the emulator by sort of launching a Gradle process and things like that, but you're not going to be setting breakpoints and jumping around and things like that. And for that kind of sort of deep, delving into your application, getting insights into the compose layout, inspector and things like that, you really have to be using the native IDE for that tool, for that platform. And that's why we really think that it's important to be able to very fluidly use the right tool for the right platform. But at the same time, everyone, the holy grail is that they want to have one source of truth, one single code base, even if it's a hybrid code base, like in our case, mostly Swift, but also Kotlin. They just want to be able to define things in one place. And that's really where we see this tool kind of bridging those two worlds, both, from a language standpoint, from a tooling standpoint, and from a cultural standpoint. And that's really what we think that Skip brings to the table.
Awesome. Yeah. No, this was really cool. This is a really cool insight into what it is that you folks built. So yeah, thank you so much for coming on the show today. It was really a pleasure having you. Of course, good luck with 1.0. Though of course, by the time that people will listen to this, hopefully the good luck will have already done its job. But yeah, this is really exciting. So where do people go if they want to learn more about Skip?
Just go to skip.tools.
Great. Wonderful. and you can check that out. No, so thank you again, Abe, Marc, for coming on the show. Really appreciate it, and of course, thank you to everybody who decided to tune in again today. We of course hope that you'll join us again on a future episode of Talking Kotlin. We have a whole lot more interesting topics already on our list, so it's gonna be a good time. All right, thanks everybody, and take care. Bye bye.
Everyone.
Bye.